Welcome to MLAC online tutorial. Before us is this question in mensuration of solid. And it said the diagram shows a fructus of a cone with its dimension. Now this is the fructus with, it has the height of 8, the base radius, or probably the smaller radius. Now the upper radius is 7 centimeter, and we are told to find the height of the original cone. Now the volume of the fructus, the curved surface area of the frutums, and the total surface area of the frutums. Now what we just need to do is to ensure, since we are asked to find the height of the original cone, now we can actually build this up to become a complete cone. Now let us see. So to complete a cone, here we have it. Okay, so here is 3, here is 7 centimeter, here is 8 centimeter, here is 3 centimeter. Okay, now but here we don't know this height, so we'll give it as what? H. Alright, now first of all we just need to do is let us ascertain what, for us to get the original cone here, the height of the original cone, so which is the whole of this cone here, that from here down. Okay, now for us to do this, let us first of all find this H here, and if I were to turn this upside down, we have something like this. Okay, so where this is 3 and where this is 7, and from here to here is 8. So this is our what? Height. Now if we now ascertain this, now you can, let us just draw out this triangle out. So we have something like this. Where the total height from here to here, take note, we have from here to here is 8, and from here to here is h, small h. So let us make from here to here to be bigger h. Okay, so from here to here is bigger h. Now the radius here, which is what? 7 centimeter. Now let us also bring out this small triangle here. Here you have what? 3, and here you have what? h. Now with this, now we can just compare this shape, which is a similar shape. Now by comparing the similar shape, we can say that this height is the same as this height. I mean, this height proportional to this, this is also proportional to this. So we can now say here that bigger h equals to smaller h over bigger radius equals to smaller radius, and the bigger h is the sum of this and this. So here you have what? 8 plus what? H over the bigger r, which is 7, equals to h over small r. So here we can now multiply both sides by the inverse of these two products, or let us multiply this, which is 21. Multiply both sides by 21. Here you have 21 into 8 plus h over 7 equals to 21 h over what? 3. So 3 here 1, 3 here 7, 7 here 1, 7 here 3. Alright, you can now multiply 3 by whatever is in the bracket here. 3 times 8 is what? 24 plus 3h, then equals, here you have 7h. Now subtract 3 from both sides, so I collect like them, minus 3h rather. Okay, so here we have, this is 24, then equals 4h, right? So if I were to divide both sides, so here we can now say 4h equals to 24. So 4 divided both sides by 4 rather. So 4 cancel 4. Our h, 4 here 1, 4 here was 6. We have about 6 centimeter. Okay, now the height of the original cone now, which is the h, will now be 8 plus h, which is now what? 8 plus what? 16, which is what? 14 centimeter. Okay, all right. For us now that we've gotten our height, let us write it somewhere here. Now our h equals to 14 centimeter. Now for us to ascertain the volume of the fructus, now this is the fructus here. What we just need to do is to calculate the volume of the total cone here minus this volume of this smaller cone. We now have the volume of the fructus. Alright, so how do we get started? First of all, we need to ensure that we identify the formula for the volume of a cone. So the volume of a cone is given as 1 over 3 pi r square h. Now since we are identifying, we are looking for the volume of the fructus here, so first of all we'll find the volume of the big one, the big cone, minus the volume of the small cone. So when we find the volume of the big cone, we now take away the volume of this small cone away from it, then we have the volume of the fructus. So here, I can now say this, let's say the volume of the fructus here will now be volume of the big cone minus volume of the small cone. Okay, so we can see that we have a common term here, that's pi over 3, pi over 3. So we can now say this is pi over 3 into r square big H minus small r h. Okay, so we identify that small h is 6, right? From okay, now the big H is what? 14. So we can now implement it. That will be pi over 3 into big R is 7 square times H here, the bigger H is 14, then minus the smaller R, that will be 3, times the smaller height, which is what? 6. Okay, so here we have 22 over 7, or that will be divided by 3 into 49 times 14 minus 9 times 6. Alright, so this one will now give us, here we have 22 over 7 divided by 3. So changing the reciprocal of this, we have 1 over. So it will be 22 over 7 times 1 over 3. So here we have 22 over 21, 7 times 3, then into 49 times 14 minus 9 times 6, that will be 54. Okay, so now let us probably punch our calculator to see what we get from this. So there we have the final answer. As we multiply 49 times 14, we have this. Now 686 minus 54, we have this. Now 22 divided by 21, we have 1.048, and when this is multiplied when this is multiplied by 632, then we have 662.34 centimeter cube. All right, that's actually the volume of the Frustum. Now let us now find the curved surface area of the Frustum. Now for us to get the curved surface area, what it means is the curved nature of the surface area. All right, so and for us to get this, what we just need to do is also to get the curved surface area of the total cone minus the curved surface area of the smaller cone to get this. All right, and this will actually give us, let us say, the curved surface area of the Frustum will now be pi RL minus pi RL. So this is the bigger R and this is the smaller r. Now this is the slant length, or what I would say, the slant length. So now for this bigger one here, it is from here to here, and for the smaller one, that is from here to here. And if you take a look at this now, from here to here, this is a right angle triangle. So from here to here, let me quickly get something done here. So here, let us actually bring this diagram out. Now this is a right angle triangle, so we can actually redraw this like this. Now this base is 7 centimeter. Now this slant height, we don't know. Now this height here, the height of the bigger one is what? 14. Okay, now for the smaller one, the base here is 3 and the height here is what? 6. Alright, now for us to find this, here we just need to apply the Pythagoras theorem. That will be x squared plus 14 squared then plus 7 squared. Then here also we have that x squared plus 6 squared plus 3 squared. Okay, all right, so for us now to ascertain this, what we just need to do is to so by evaluating, we have that x squared equals to 14 times 14, that should be 196 plus 49. Now this should be 6 plus 9 here is what? 5. This is 9 plus 4. 9 plus 4 is 13 plus 1, 15. 2. So automatically we'll find the square root of 255. Alright, let us put it at the positive value of x, which is what? 15. Okay, alright, so and as such again, let us also find the value for this smaller slant height. This is 36 plus 9. Now our x here square rather now give us 45. Okay, now the square root of 45, the positive value, the square root of 45. Now ascertaining that, we have, so here we have the square root of 45 to give us 6.7 centimeter. Okay, sorry, I'm sure this is wrong. This should be 45. Even the square root of 255 is actually not 15. Sorry for that error. Now the square root of 245 is 15 point approximately 7 centimeter. Okay, So with this now, we've gotten the slant height. Okay, so what we just need to do is to now implement it here. Curved surface area. Here we have 22/7 times the bigger R for the bigger cone is 7 times, then the bigger L here we have what, 15.7, then minus 22/7 times the smaller radius, that will be 3 times 6.7. This can cancel out this, so we are left with 22 times 15.7 times okay, let me just multiply through. So here we have it. When we multiply, we arrive at approximately 345.4, and when we multiply this divided by 7, we have 63.17. And when we subtract 63.17 from 345.4, we have that the surface area of the Frustum is now 282.23 centimeter square. Okay, all right, the next one is the total surface area of the cone. All right, total surface area of the cone. All right, so let me quickly ensure that everywhere is okay. Now the total surface area of the frustum. Now for us to get the total surface area of this, which is this, alright, now what we just need to do, the total surface area is giving us, if it's actually closed, both of them are closed. So here we have big R plus small r, then plus pi big R square plus pi small r square. That's the total surface area of the frustum. And for the slant height, which is this slant height here, what we just need to do here is, now the slant height from here to here is actually giving us from here to here, slant height is giving us 15.7, and the slant height from here to here, I guess we got 6.7. So for us to get from here to here, what we just need to do is to subtract this from this. So that will give us 15.7 minus 6.7. This should give us 0, and this should give us 9. Okay, so let us now implement it here. 22/7 times 9. 9 to the small radius, big radius here is 7, plus 3, then plus 22/7 times big radius, 7 times 7, then plus 22/7 times small radius, that will be 3 times 3. Okay, this will cancel this, so here we have that will be 3.142 times, this is 10. 10 times 9 we have what, 90, then plus 7 times 2 here, 14 remainder 1, 14 plus 1, 15, then plus 3.142 times 9. Alright, let's get this done quickly. Okay, by punching our calculator. So here we have, so there we have it. This times this will give you this. So if we are to add everything together, 282.78, then plus 154. So we have 4 264.98 approximately. So here we have the total surface area of the frustum. Alright, this is the final solution to the question. And if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in mathematics, physics and chemistry. Thank you and God bless you.